Okay, handout 3 is on estimating square roots. So you will not use a calculator for this because we're estimating. So a little review, we know that perfect squares are numbers whose square roots are whole numbers. I'm going to use the number sign. Examples would be like 64 or 4 or 196. Because when you take the square root, I'm just going to put the square root sign over all of them. You have 8, which is a whole number, 2, and then if you look on your paper in the front of this unit, 196 is 14. So those are all considered perfect squares. My poster, which I'm going to write the word poster here, on that corner over by my desk has that diagonal line drawn through it in red, I believe. And that's all the perfect squares up through 100. They obviously go on forever. So I think of it as 2 times 2, 3 times 3, 4 times 4. It's any number times itself. So non-perfect squares are numbers whose square roots are not whole numbers. So examples would be 6, because there's nothing times itself that equals 6. 45, 180. I mean, it's just anything that doesn't have a number times itself that would equal that number. So those would all be those irrational numbers. Okay, so we can use our knowledge of perfect squares to estimate the value of non-perfect squares. So when they say to estimate the value of 50, you know that's not a perfect square. There's nothing times itself that will get you to 50. So they say to use a number line to help you locate it. I don't draw a number line out, but I kind of put 2 numbers like this. So we know that 50, and you can use your sheet if you need to. I just think to myself like, okay, I know that 7 times 7 is 49. And so I go ahead and without the number line, I'll write like 7 here with maybe like 49 above it. It's the square root of 49. And then it has to be between them. So the very next number is 8. And so I know 8 times 8 is 64. So we know it's between 7 and 8. So it's obviously going to start with 7. And so then to determine which square root it's closest to, you think about, you're finding the number 50. So 50 is only one spot, or, one number away from 49. And it's 14 numbers away from 64. Oh, there's my dog. And, and you don't even have to know those exact numbers. You just know that it's closer to 49. So since it's closer to 49, the square root will be closer to the 7 than the 8. So it should just be a little over 7. We know it's going to start with 7. So a good decimal estimate would be like 7.1, maybe even 2. Where you don't have to be exact, obviously. Because if you do it on your calculator, if you go ahead and try square root of 50, it's going to be like 7.1 or 2 and like go on forever because it's irrational. But it definitely isn't going to be above 5 because 5 would be the halfway point. Okay, so you might want to rewind that and listen to all that again, or let's try number 2. So if we estimate the value of the square root of 22. So I look on my paper, or I think to myself, I know that 4 times 4 is 16. And so we know it's between 4 and 5. So I know it's between 16 and 25 because that's those perfect squares. But I know that 22 is closer to 25. So it's closer to the 5. But it always starts with the first number. So it's 4 point. And since it's closer to the 5, you know it's over the halfway point. So really anything over 5 makes sense. Anything over that half. So I'm just going to say like 7. It could be 8, 6. Just you don't put 5 because it's not exactly half. Okay, so you go ahead and pause it and try number 3 and see what you get. Again, you can rewind and listen to those again. Okay, so you should have gotten, it's an estimate. 10.1, 10.2, even 10.3 would be okay. Anything below the 0.5 mark. Okay, so on to the back. We have, and this would definitely be a lesson that you would want to do the homework on at least sometime, because it takes some practice. Which of the following square roots is best represented by point A? So the way I do this is I know that 3 on a number line is also like the square root of 9. And I have to write this even now. And 4 is the square root of 16. So I see that A is closer to the square root of 16. So obviously I know the 7 is out, the 8's out, and then you have to think, would it be 12 or 15? Well, it's pretty close to the 16, so the square root of 15 makes more sense. Okay, 5. Which of the following would be the best estimate for 198? I'm going to have you try that. Remember, use the front of that paper. And then this says, between which two integers would each of the following lie? So that should be the whole number. Like, you're not putting square roots here. You're putting the integer. And then you will look at number 7. Rebecca bought a square table for her kitchen. So you know it's a square. The area is 65. So before, we always took the square root of that to find the length of one side. Well, now it's not a perfect square, but we're still doing the same thing. It just won't be a perfect whole number. So go ahead and pause and try those. Okay, so if you look back here, number 5 would be A. I put the 2 perfect squares that it's between. I looked on my sheet for it, and that's in 198 is close to 196. So the best bet would be 0.1. 5 would be right in the middle, and we know that's not it. 6, I put the perfect squares around each one. And then the square root of 81 is 9. Square root of 100 is 10. So that one you're just fine. You don't even have to do the decimal for that. Okay, and on this one I forgot to do. So the estimate of the square root of is 65 is between the square root of 64 and the square root of 81. So that is 8 and that's 9. So we know it would be 8 point something. And 65 is right after that. So the only thing that would make sense would be 8.1 feet. Okay, and then create and label a point on the number line to represent an estimate of the following square roots. So again, I'm going to pause it. And if I was you, I would put the perfect squares around each side, or at least think about them. And then you estimate the decimal, and it's just an estimate. Yours aren't going to be exactly like mine on the number line. So go ahead and do those. Okay, so if you look real close, I put the perfect squares around each number. And again, you can pause it if you need to look at it longer. And then I put my decimal underneath there. The ones you might have thought I had to think a little bit about was like letter B here. I knew that 81 to 88 is 7. And 88 to 100 is 12. So that's why it's closer to 81, but it's never going to be exactly 0.5. It's not in the middle. Let's see. Same with this one. 118 is closer to 121. So I knew, and you could do 0.789, any of those. And then this one, it was real close. So I had to subtract. So 49 to 56 was 7. And then 56 to 64 was 8. So it's closer to 49. So I knew it was right below the halfway mark. Okay, I would definitely practice the homework on this. or at least plan to do it in a few days or so.